Okay, here we go. This is a polynomial function. You need to have memorized that it's like you should have a card that says polynomial on one side. Like it should say, like, you know, f is a polynomial on one side. F is a polynomial. Fresh words. Flip it over. So don't write anything. Like, understand first. Once you understand, you can figure out good ways to abbreviate and write things more concisely. So the goal is not to copy. It's easy to copy. You can take this whole class online. Okay, if f is a polynomial, that means f and f prime and f double prime and f triple prime forever. So f and all of f's derivatives, they're all continuous and they're all differentiable. So if f is a polynomial, then f and all of f's derivatives are continuous and differentiable. That means no jumps, no removables, no vertical asymptotes, no corners, no anything. Just nice, smooth graphs. Differentiable. So if f is a polynomial, then f and all of f's derivatives are continuous and differentiable. Which really, to me, mentally says, when I think of the graph of f, or the graph of f prime, or a graph of anything, I don't have to worry about weird stuff. It's just like a nice, smooth graph. Okay, so they show f double prime in the table, and then they ask which of the following must be true. Somebody the other day, so don't talk. Somebody the other day figured out that the AP test writers really like to put the statement must be true, because that allows them to have some of the statements as could be trues. Do you hear the difference? Yeah, that would be the appropriate reaction. It's quite a battle. No, really. That's what I say. I don't think, well, here's my theory. Okay, nationwide, about 57% of the country will pass the AP test. And I believe that it's about 57% because far too many people just still believe they can memorize. Like, they don't have to understand. They'll just memorize enough problems, I can do it. And you just can't. Like, you have to make sense of it. That's why I push you really hard to make sense. Because when you make sense of it, then 91% of the class will pass the test, okay? Instead of 57. F is increasing on the interval 0 to 2. So I look over here. I'm supposed to figure out if f is increasing. But all I have to look at is f double prime. So there's no indicator based on f double prime as to whether f is increasing or not. So I actually don't know if this is true, false, or I don't know. I just don't see any information that helps me. So not having any ideas, I'm just going to move on. I don't want to get stuck. I mean, like, I have a table, right? I could find the secant slopes up here, but that's not going to help me figure out what f is doing. That'd just be secant slopes on f double prime. F is decreasing, exact same reasoning. Raise your hand if you understand why I just said exact same reasoning. Come on. Point. Here's the reasoning. If I was trying to figure out if f is increasing, and there's nothing here on f double prime that tells me that, well, there's no reason to think I can figure out that f is decreasing. Exact same logic. Okay? Questions?
Wait, so f increasing or decreasing would be true, but it's not must be true because you can't figure that out.
Can't say it better. Based on the data they're giving us, all I have are data points of f double prime. Danica's chart shows the relationship between them, and there's no indicator on f double prime that tells me when f is increasing or decreasing. Perfect. Super Luke. Okay, item C says f has a local maximum. Okay, I don't have to even think. Who knows why I can do that, like instantly? Like I've already figured out C without doing any additional thinking. Who knows why? I'm trying as hard as I can to get you all to understand. If you don't know the why of these things, you've got to ask about it. Like it's not just going to happen. Like you're not just going to suddenly go, oh, I figured it out. Like what's the why part?
Because the local maximum is where it's changing from increasing to decreasing, and we've already said that we can't find those.
It's perfect. I've already figured out that I can't determine when f is increasing or decreasing. Well, f has a local max when f changes increase to decrease. So if I couldn't figure out when f was increasing or decreasing, there's no reason I can figure out when f has a local max. Okay, this class is all about logical thinking. A highly prized skill in today's society where everything is becoming automated. Like no one has to do repetitive tasks anymore. They won't pay you to do that. Like they're going to get phased out. They're going to become automated completely. Okay, so you've got to learn to think in a logical way. Questions? Cool. Next one. The graph of f has a point of inflection at x equal 1. I have memorized. You need it memorized as well. It's on that white, sheet protected sheet. That f has a point of inflection when f does this. So if f does this, then f has a point of inflection. Well, I'm looking at f double prime. So I want to see if f double prime does this. So I look at the data, and I see f double prime has a value of 5, then a value of 0, then a value of -7. But remember, the table only shows selected values. So the f prime double prime graph might do this. Which would mean f double prime changes positive to negative at maybe 1.2 or something, not x equal 1. So it's back to Brecken's observation that there's a battle going on here. F prime could have gone through, like f prime could have done this, in which case this would be true, could be true. It's not have to be true, it's only could be true. We got 90 seconds. Question. E has to be true. Because f prime is continuous, because f was a polynomial, the graph of f double prime has to go from positive to negative somewhere in this interval. So that's the one that's true. Good work.